And this is, of course, on a smaller scale, but anybody having some engineering background, even just, I would like to say common sense, if you can read the numbers on this and understand what we're truly able to capture, it gives you guys a real idea of what the maximum power transfer solution does. So what we have here is a 2-horsepower motor that pushes, I think, no more than 15 amps, if I'm not mistaken. And we have one of our models that's a 25 amp model unit. Basically, as I turn this piece of equipment on, I haven't even turned the circuit breaker on for our technology yet. Now, the good part that this demonstrates is that, God forbid something happened, our technology went down, the power could still run through and work effectively. So as I begin now to turn on the breaker, we start to see the numbers here start to come up. You see it's pushing 11 amps, which is pretty standard. Between 10 and 14 is what we see. The power factor is at 0.42. The kVAR is at about 1.0, and then you have kVA at 1.3. So we still haven't turned our equipment on as of yet. So now as I turn the switch to on, you're going to see immediate power factor starts to rise. It's already going to 0.5, and it'll end up at 0.98. And the kVA will begin to drop, and it'll get to about 0.5, and you'll see the kVAR will get to about 0.2. Now the amps are already dropping. It's already at 8, and it'll probably settle in at about, I would say, 4 amps, 4.5 amps. So right there, we're demonstrating the ability to reduce power, and reduce current. The kVA is at 0.5 right now, and the amps are right there at 4.4. So, I mean, I like to say I'm not a physicist or an engineer, but I could see the proof is in the pudding. You can see here that it's doing all as advertised. What's remarkable about this technology, I took this on the road and I drove to Kansas. I know you guys are saying, what are you driving to Kansas for? I drove to Kansas and I stopped in every state. I stopped in Arizona, I stopped in Albuquerque, and I hooked this equipment up at every place that we stopped at. And what was amazing is the amps were different everywhere because the power was different everywhere. So some places were giving us 14, 15 amps. Some places were giving us 9. Some places were giving us 8. No matter what, this machine balanced it out to the same place. So that was the exciting part, that it was doing its job the same way, no matter on what power conditions, which showed that this motor was working harder in different places. So that shows that we have the ability to make it work more efficiently. Now, as I turn the equipment off, you're going to see all the numbers immediately go right back up. The power factor from 0.98 is now at 0.4. The kVA is up at 1.3 immediately. And you'll see the amps are at 11 just by turning it off. So we know what this can do in large scale manufacturing facilities, hospitals, office buildings, and those are the markets that we're really starting to conquer. Without further ado, I'd like to bring the man who put this all together and made it all possible for us to be here, Adil Khan, so he can get into the more technical side of what we're doing here today. Adil?
Thank you, Joshua. And thank you, Joe. And thanks for the college for bringing this in here.
You're welcome.
And
we're trying to make California companies more globally competitive.
Yeah, we appreciate it. My name is Adil Khan. Very easy to remember my name. Adil, like a good deal. So make deals, better deals, and you'll never be disappointed. So thank you for being here today, this morning. I know Los Angeles is not the best of places to be in traffic. So despite that, all of you are here and ahead of time. So I'm very honored and privileged to have a good audience and a house full of people. I would like to ask you a few questions. This is going to be an interactive discussion. I don't like to do lectures and presentations and stuff like that. I would like to give you what you want to take when you leave from here. So first of all, how many business people are here? Entrepreneurs and business people. How many technical people, engineers are here? How many operations people are here that actually work on? Very good, very good. So we got a very good mix of people here, and I'm anticipating that we'll have some great questions. So you can ask business questions, you can ask technical questions, you can have operations questions, so you can ask financial questions. How many finance people are here? Okay. So without the finance people, supporting it, it's very hard to get through. So we got to give them a lot of importance. So having said that, what we will do here is I will set the stage with some basics. We are here talking about electrical energy. Okay, it's a subject that is not even easy even for electrical engineers, because electrical engineering is very broad. And in electrical engineering, energy efficiency and conservation is a very small part of electrical engineering. But that small part has an impact on everything that uses electricity, whether it is lights, whether it is motors, pumps, air conditioners, computers, it doesn't matter what. Whatever uses electricity, energy efficiency and conservation is going to have an impact. So are we all ready for some basics of electricity? How many of you have heard of voltage? Good? All right, we are good there. How many of you have heard of current? Everybody? Anybody here that doesn't know current? It's not the current in the river. I mean, I'm talking about the current in the wire. How many of you have heard of power, electrical power? Where does electrical power come from?
From here, Southern Cal Edison.
We asked the same question to a bunch of students in a school, and we asked them, where does milk come from? They said, grocery store. Well, from before that, where does it come from? In a gallon tank. They have no idea it comes from a cow. So electrical power today, you use it everywhere, but very few people know that there is a place that's a source for power. And power, electrical power, all started with watt. Comes from a person's name called James Watt. Everybody know James Watt? So what's a watt? Comes from the surname of James Watt. So watt, and then everybody has heard of kilowatts. Kilowatts, right? That's the term that everybody is very familiar with, kilowatts. But what is a watt? Let's understand what is a watt. Watt is nothing but the multiple of volts times current, which is amps. Simple enough? Basics. We're all good with that? Kilowatts, kilo means 1000. So it is nothing but volts by 1000 times amps. What did Joshua demonstrate to us right now in this equation? Reduction in amps. What happens when you reduce amps?
You reduce your electricity consumed and your heat generated.
So your demand, your consumption, all that has an impact by just this one element here. So that's one side. Let's set it up. Now, how many of you have heard of an electrical socket? What is an electrical socket? I didn't see any hands. I saw only 3. All right. For those of you that have no idea what an electrical socket is, this is an electrical socket. Okay? So let me also draw it. It kind of looks like this. One pin is longer, one pin is shorter, and there's a circular one. It almost looks like a happy face. That's an electrical socket. How many of you know an I'll ask you. You give me the answer. What is this? Ah, good job. Breaker box electrical panel. Fantastic. We don't have any caps or shirts to give away, but we'll take a rain check, okay? So you have a socket, you have an electrical panel. Okay, now let's go a little bit further. What is this? Another symbol could be this. A transformer. Has everybody heard of a transformer? So, just so that we don't get confused, this is a socket. This is an electrical panel. It's there in everybody's house, okay? If next time when you go into your garage or into your basement or into your laundry room or closet, start looking for it. It'll be a gray box. It'll be, so that's an electrical panel. And then transformer is what's sitting outside your Los Angeles Water and Electricity Department when you say that, hey, I'm building a home or an office or a factory and I need electrical power. They'll say, oh, we need to put in a transformer. So we need to know how much your load is. How much are you demanding? And then they come and install a transformer. Transformer. Now let's go a little bit, one more thing. Let's see how many of you can tell me what this is.
No, we didn't know you were an artist, too.
So what is this? A coal power plant. Okay, so just so that we don't forget, I'm going to write it. Coal power plant. I heard somewhere, and I read it a lot, they say that people have a very short memory. The finance guys can relate to that. Every time Wall Street takes your money and converts it into paper, people forget it and go back and give them more money. So people have a very short memory. Right? How many times do people want to give money to those people that want to take it away and take it away and take it away from you? Some people get lucky though. So that's the whole purpose for doing that. Anyway, back to electrical power plant. I don't know how many of us really visualize, just like that milk in the grocery store comes in a gallon from a dairy plant, and the dairy plant collects milk in containers, like milk containers that go to dairy farms, and the dairy farm actually has cows where it's milked mechanically and transported. Let's see how this comes together. This electrical socket that you see here, that when you plug in something, instantly says charging. Right? Everybody knows what that means. Or you plug in a lamp, the light comes on. So this actually behind the scenes in the wall is coming from electrical panel. The reason why he said we have a 2 horsepower motor and this operates between 10 and 14 is the capacity of this breaker is only 15 amps. Right? If you go more than 15 amps, it'll trip. Now, this panel gets its power from where? A transformer. This transformer gets its power from where? Power plant. This is the whole sequence of how power has a source. Then in between here and here, there is transmission. You know, you see those big wires and big towers. So it comes through that and reaches us here. Now, how do you rate a socket? It is called a 13 amp socket or a 15 amp socket. Everybody with me? How is this electrical panel rated? Anybody? Huh? 100 amps. Let's jump to 200, 225, 400, 800, 1000, 2000, 4000, all amps, right? How's a transformer rated? kVA. What does kVA stand for? Voltage times amps, kVA. What are generating plants? It's called MVA or MW. Mega. Because it's in millions of watts is the power generation. Why did I bring this up? Why did I bring this up? They all have amps in common. What is amps? What is amps? It's the energy to do work. Until something is turned on, is there a bill?
Yes.
There is a bill. Okay, finance guy, there is a bill. But until you turn a switch on, there is no work that is done. Who does that work? Current, the amps does the work. So until current flows, you don't have something on the bill that can charge you. Right? Because if anything multiplied by 0 is 0. But he's right. Our government, IRS, electric, they will figure out how to charge you not only for what you use but more. So what are the two things that MPTS does that affects the efficiency and affects the dollars on your bill? Okay, let's take another moment here, and I'm going to draw another picture. Spencer loves this picture. Yeah. You know, because we all grew up with that mom showing us A for apple, B for ball, C for cat. You know, that's the best form of learning. That's how we learned the 26 alphabets. If I said umbrella, all of you know what letter we are talking about, right? So, let's put a picture here. No, but that's very basic, but that is how the human mind can grasp it. A picture is worth 1,000 words. You can read a paragraph many times to understand what you'd understand from just looking at a picture. So here we go. So you have, what is this? There's a power pole outside. What is this? Cash cow. For whom? It's a meter for the Los Angeles Water and Electricity Department. What is it for you? It's a way to make sure that you have place in your pocket to put in more money. Because unless you give it out, you can't put more in. Okay? That's what that meter does. And then when you go here, now you have a beautiful glass building. And it has what we call it as electrical load, right? Computers need electricity. Air conditioners need electricity. Anything you use needs electricity. You wondered how you lived without a phone. Even that phone needs electricity. So your lifeline is, I saw Joshua this morning, before he was thinking of coffee or food or whatever, I saw him grab one charger, wind the wires, and quickly make sure he has it, because without that he is dead meat. Electrical load. Now let's say that a building has, let's say it's operation, this college is now in operations, okay? Let's say that it is demanding 1,000 kilowatts of energy. Okay? So what is this power plant doing to support that? That power plant is generating 1,300 kilowatts of power. Everybody with me? What's the difference between the two? What's the physical difference, visual difference between the two? 300 kilowatts. What happened to that 300 kilowatts? It's the loss. So what is efficiency defined as? Efficiency is output divided by input 0.77. 77% efficient in this scenario. What did Joshua show us? When he turned this motor on and this was off, he showed us 42% efficiency. Right? If you don't believe, you should come back, turn it on, take a look at it, okay? Because people in general are very skeptical. So Joshua can show it to you again. So it was 42, that motor efficiency. And it has got two capacitors. Why does this have capacitors?
To increase efficiency.
To increase the efficiency. So the increased efficiency of this motor was how much? 42%. The only way the world knows today to change that efficiency is to take this, throw it away, bring a new one which may operate at 0.6 or 0.7, 70% efficiency. That's the only way the world knows what to do it. Somebody says, hey, you have an old air conditioner. It is very inefficient. That's why electricity bill is more. What are they telling you? Throw away that air conditioner, it's old. It's inefficient. It's working fine. It's actually more reliable than any new thing that you buy, because everything new that you buy, you throw it away in less than 5 years. For example, your car. My dad's car, a Fiat, is still working and it's still there. I have gone through how many cars I don't even want to mention. Well, how many cars have you gone through here? How many have you gone more than 3 cars? So the world is saying, throw away the absolutely good stuff and go buy another one. And the air conditioner is operating at, say, 70% efficiency. So it is, you're paying more. They say, hey, throw it away, get a new, more efficient air conditioner, and you will now be at 0.83. The most efficient air conditioner in the whole world is 83%, made by Trane, and Carrier has some models. Nothing is more efficient. So efficiency is an indication. So if you say it is 77% efficiency, what are we actually saying? Finance guys, what are we saying?
Wasting money. 23% inefficient.
So 23% you threw away, right? 70, you paid for 1300 kilowatts, you used 1000 kilowatts, you threw away 300 kilowatts. What is the cost of 300 kilowatts in California? About $20 what you have sent me those bills for. 300 times 20 is $6,000 a month. Times 12 months, 72,000. Times 10 years, 720,000. Times 30 years, 621, 2.6. Finance guys, I hope this engineer is calculating right. 2.160 million. The reason why I did that exercise was somebody handed me a proposal that is from another energy initiative that has spelt it out like that and said that if you can increase your efficiency, then what does it equate in dollars? Okay, so now comes in the MPTS unit is not going to ask you to throw this motor away or a compressor away or an air conditioner away or a pumping station, motor, your electronics, your old inefficient stuff. It is not asking you to throw it away. It says keep what you have, just put this in line with that and turn it on, and what are you going to see? You're going to see the 1,000 probably goes down to 950 and that goes down to 1,000. So what happened to your efficiency? Now you're 95% efficiently. That is the reason why MPTS, Maximum Power Transfer Solution, is called a disruptive technology, a game-changing technology, because it changes the game, because there's nothing in this whole world or in this whole universe right now that is known that can change the performance of an existing equipment without throwing it away. How many of you would like a 95% efficient application? Thank you. That's what an MPTS is capable of doing. In electrical engineering, what is the term used for efficiency? Power factor. How many of you have heard power factor? Now, just look at the name itself. It's called power factor. We keep forgetting that words were not coined just out of the blue. I mean, today they are. I mean, the slang. Today you are. Okay. But originally, when language was made for us to communicate with each other, that word actually implied what it was. For example, how many of you have passports? Why is it called passport? It was actually a document given to somebody to pass through a port. Earlier you didn't have airports, you had seaports. So you went in a boat and countries said, we don't want these group of people to come in, but we'll allow them to come in if they have a document that allows them to come through. So that document said, if you show that document, you can pass through this port. Pass through the port. Passport. Then instead of trying to say, I have a document to pass through the port, it became passport. Power factor is also similarly has a reason why it is called a power factor. 1,300 kilowatts of power got factored by 77% to make it 1,000 kilowatts. So you're passing 1,300 from here and you're getting 1,000 there. So in electrical language, they said efficiency is for all these other guys who didn't go to a technical school. So this can be more for the engineers only. So they made it power factor for technical guys and it's efficiency for this. Now we can easily derive this. This is not very hard. We said volt amps is kVA, right? Volt amps is kVA. So let's write down efficiency is equal to total power times a factor, okay, times some percentage, okay? Efficiency. This is efficiency or a factor. PF. Okay. PF, okay? KVA. That is 1000, correct? 1300 times the factor was output. So this is output on top. Input is KVA. With me? It's basic second grade equation, which we may have forgotten. Some of us don't remember. Can I cancel that? We still remember that? Or we need a calculator?
That's 8th grade, Adil.
Because I've had PhDs and MITs argue with me that said efficiency is not power factor. Now I can go a little bit deeper, but we won't care. I can go into cos theta and sin theta and convert that and, then get it. That's a long way for those guys. But this is good enough. Right, Joe? Are you happy, Joe?
I'm very happy.
All right. Very good.
It's a good day learning. You learn something new.
Yeah. Okay. So this is now, you have understood from start to the end points. The motors are connected here. Air conditioners are connected here. Computers are connected here. Your lights are connected here. You have all kinds of stuff that's connected. That is how things work. So what we actually did here that we showed you was, we are taking a source. I'm going to draw that same picture again. You have an M and you have the load, electrical load. I have 1000 kilowatts. Don't replace that, okay? It costs millions. People say we change to LED lights. I saw Ameresco wins a federal government contract for $5 million, and they're going to save $100,000 every year for the next 25 years. What are we missing here? Everybody is looking at $100,000 a year in savings. They missed saying that dip into your pocket and pull out $5 million to save $100,000. Right? That's what's going on in this world. LED, next greatest thing. Nobody thought about it. Let's do it. VFDs. Oh, VFDs. Power is giving us a rebate. Let me go get it. I'm going to get a $200,000 rebate check from the utility. Let's go put in VFDs. Whether it makes sense or whether it doesn't make sense. No, we are getting that $250,000. So let's go buy a VFD. Nobody stops to think, was that VFD necessary there or not necessary? Did the efficiency go up or go down? All it did, yes? Or worse. But it saved you $300 on your bill, and it gave you $200 in rebate for each year VFD. So let's go do it. This is what's happening with our world today. So let's come back here, back to this beautiful picture that my mother would be happy that I could draw. We have this. All Joshua wants to do is introduce. Don't touch this, don't touch that. Put MPTS here. Or here. Or here. Or here. Where is the meter? The meter is here. Meters, MPTS here. So let's look at this here. The moment you did this, what happened? You got, this became 950, and this became 1000, and your building efficiency became 95%. At this point, I think it's good to digest what is here. I will pause and you guys ask me questions. Yes, please.
So if you put in a couple MPTSs, can you get to 100%?
Excellent question. That is the excellent. Give a round of applause. Because the traditional mindset is, why do I need to put a couple or three here? Why don't I simply put one big fellow here? That is the usual mindset people ask. So you're clarifying that question because this transformer is rated at, where do we have that? Say 2000 amps, right? Let's say this building is rated at 2000 amps, that is drawing. So the transformer and the main switchboard, main distribution board, is rated at 2000 amps. Now, this is not an easy question, but I'm going to ask it. Some people may know it. If your main distribution board says 2000 amps, and your service says 2000 amps, your drawing says 2000 amps, main distribution for this building, what do you think is the current flowing through that meter? Maximum current flowing through the meter. Very important question. So I'll let you think and answer. What's that? All right, I'll set that aside. He's going too deep from an engineer. I'm talking to business people here. Okay. Yeah. Anybody? What is the current running through this meter on this 2000 amp main distribution panel?
No more than 2000.
No more than 2000. Okay. When does it handle 2000? I'm going to have a leading question.
When everything's on.
When everything is on, every single socket is plugged in. Every socket is plugged in. Every light is turned on. Every projector is on. Every camera is working. Every computer is working. So you got every single thing working and it's on. Then you are going to use 2000 amps. Everything's working, right?
On maximum power.
Yeah, maximum power. That's the most you can switch on in this building is 2000.
It's actually
Yeah, max. Now we can answer her question. Is she an intelligent person in this room or what? She says, why am I going to install a 2000 amp MPTS when Joe knows not everything is on all the time? I can count a lot of sockets that are not plugged in right now. And if you walk out, you can see a lot of lights that are not on. You can see parking lights are not on. I hope so, during the day. Okay. All right. And then air conditioners are not on yet because it's pretty cool, right? So what you really see happen is the ratio of 1:4 or 1:5. So if you see 500 amps on this meter, you're doing pretty good. So how efficient is that service? 25% efficient, right? 500. So to your point, if you can just track where these 500 amps are coming from, let's say it is coming from, this is connected to a meter. Oh, there's an air conditioner. Oh, there's a lot of sockets. Let's do one thing. Let's put the MPTS on this panel because 400 amps is coming from here. How much money did she save? What's your name, please? Kathy. How much money did Kathy save this chief of operations, the most brilliant engineer, and the best electrical energy efficiency consultant that comes there, who says, why don't you make one big MPTS and put it here? And then they start asking, what is the payback? What's the ROI? How can you, already you don't have an ROI on that building. Did anybody question why we have 2000 amps MDB when you're using only 500 amps? Nobody does. Did somebody ask why you have 20 sockets in this conference room? You know why? I'll give you the real reason. Code requirements is one, but in the name of code requirements, the design engineers will add more than the code because they tell you, Joe, you have students here. Everybody might come in and they're looking for a plug point, so we need to put it in. But what they're not telling you is, my fees is 6% on the total value of the project. Architects get paid a percentage of the total project. So you started off with the architect increasing your cost of your building by $1 million to make $60,000 for themselves. Beautiful, right? So what, Joe? You can build $1 million because I need $60,000. My daughters go to college.
How about if I just give you the 60 direct and we forget the million?
Has anybody come to you and told that? Please, I'm going to charge you $60,000 more in fees. Can you please pay me? You will say, go get your head examined. Why should I give you $60,000? But you're willing to spend $1 million and then pay 60. So you're willing to spend $1,060,000 because nobody laid it out like an engineer did. That's what's happening. Back to the train of thought here. You pick only those 400 amps that are critical. Like you go to a grocery store, only the compressor racks, the refrigeration takes more than 80% of the entire lighting load. Electrical load. Am I right? He's in refrigeration business, so that's why I'm looking at him. I don't know, there may be others here too. Now, in a commercial building, the biggest load that you have is the air conditioning chillers and the pumps associated with it and the air handling units that are blowing air. That's what is associated. There is a panel called M, mechanical panel. There is a panel. The panels have names. It could be a lighting, or it could be mechanical, it could be refrigeration, or it could be something. If the architect decided to put his name on it, he might put his name on it. Okay, so what happens is, M and R panels is what we need to look at. Now here is another thing. How do you increase the cost to $1 million in a building? What you do is, you start adding up. I'm talking about the mechanical and electrical part of design. The code is the National Electric Code is the excuse that is being used. And then what you do, you put one motor here, one motor here, one air conditioner here, one air handling fans here. So they make it harder for you to get efficient. And then this is a 100 amp panel. This is another 100 amp panel. This is a 400 amp panel. And this is a 200 amp panel. This is used, 30 amps are being used. 30 amps are being used. AC, okay, 200 amps are being used. 75 amps are being used. Very efficient. And people want to know, hey, how efficient is this? What is the payback? What is the ROI? My dad used to say, when you're sitting here at the table, God bless his soul, I learned a lot from him. He's gone 33 years ago. When you see an ant that crosses here, most people take their finger, crush it. Human nature. There's a mosquito sitting there, you kill it because you see it. And he says, there's an elephant going behind you, there's a tiger going behind you, and you don't seem to even notice it because you just don't know, it passed. That's what I would like to communicate to decision makers and leaders. Be leaders. The leaders are paid to make decisions. Everybody else in the company are paid to do what they're asked to do. They don't make decisions. Are you going to pay them more if they made a decision that is very good? Are you going to pay them less if they did not make that good decision? Joe?
Well, it depends on their incentive comp program. We'll have to decide how they did against their metrics for the year. So maybe, but generally not.
So why should a middle-level manager or a engineer says, you know what, I already have enough headaches. I can see this is a beautiful thing, and but if I do that now, I got to go get all this information, and then I have to worry about all this thing is scattered. It's not rocket science for the guy that does it. He will simply pull all that into one panel and says, this is the M panel, and you got your motor, you got your AHU, you got your HVAC, and you got your whatever pumps. And then you say, okay, let's put the MPTS unit here. So now I accomplished what Kathy wanted me to accomplish. We are dealing for 400 amps. So without actually worrying about all the 2000 amps, you, by just putting one MPTS unit there or two MPTS units on two panels, you actually made that whole building greater than 95% efficient. We have factories operating at 98% efficiency with all factory equipment, their air conditioning, their computers, their VFDs, everything put together. When the utility is looking at the meter and looking at the sine waves in their office, they're saying, what happened to this factory? This factory has been operating at 73% power factor for the last 20 years. What happened in the last 3 months? It is showing 0.98 power factor, 98%. We are now having utilities come to the customers, which they never did before. And some utilities in Colorado, their demand side billing department is going to the customers. I have some letters, you have some letters. They're saying that your meter must be broken, so we're going to change your meter. And they come and change the meter. All the customers that are using this, they expect in May, June, the bills to go up. And the bills didn't go up. Actually, some went down. Because the heat went down, and then the air conditioning inefficiency, it doesn't exist anymore in the building. So the billing department goes there and changes out their meter because they think their meter is broken. And we receive letters, 2 or 3 letters from several of our customers every summer. With that, I would like to take more questions if you have. Sorry, long answer, but you led us into some very detailed discussion.
So real quick, tying in, there's no way to get to 100 with impedance or whatever to answer Kathy's question, or is there? Because she asked,
yes,
how could you get to, you're at 98, well, she said 100, I just want to be clear.
She was more hypothetical. There is nothing that is 100% efficient in this world. If I say we can get to 100%, don't believe a thing I say.
But I was wondering if there was a way to see how your diagram has like socket panel
Yeah.
and MPTS there, and then
Yeah.
of course you were getting some on the other panel side. So if you did one on that panel, on that mechanical panel, and then you had one at the socket level, would you get a factor of 2? Would you come closer to 100%?
What we have seen is,
Hey, Adil, wouldn't it come down to?
99.26. The answer is yes, because you're asking an engineer. I am trying to say it is 0.9926 is what we are seeing. Realistically, can I make it 1.00? I can make it 1.00. If you do 2 digits, it shows on the meter. It is 100% efficient. Answer is yes. Answer is yes. Okay.
You know, are you going to talk about scalability? Because we have all kinds of folks here represented.
Yeah.
Some have, I'll make it an accountant's phrase. Some of them have $10,000 a month electric bills, and some of them have $100,000 a month electric
Yes.
bills. So talk about, are you going to talk about scalability? a little
Yes.
bit?
No. We can, if you want it now, I'll answer that question right now.
Well, let me ask one quick question first. On this power factor of 42%, and it went to 95.
Correct.
This is without a load. It's just free running.
Yes. It is exaggerated. It's a little bit exaggerated.
Yeah, and so we've been looking at some of the chillers on some hotels that we were looking at, and they're running at 70%.
66 to 72% is the right value for you to assume on any air conditioner, unless it is a high efficiency new generation air conditioner which will run at 0.8 to 0.83. That's the best, yeah.
So
The question
it's
is,
an anomaly here that this motor, it's just the way you have to demonstrate it because it's only 42% without load.
well, everybody likes to see dramatic. They like to see drama. If there is something that is very, very clear, just facts and whatever, people lose interest. So I have tried this motor with a fan. And I put a fan here, and that air is going to blow so hard, all the papers start flying. I have done that. I brought that, and I've tried to put some pump just to circulate, the water, to put some water in. Now it becomes wet. Joe will say, I'll never have you back again in my conference room. So therefore, I had to compromise and say, anyway, this pump motor is a brand new motor. It's running at 42% without load. With load, what do you think it's going to run? 0.60?
Yeah, maybe.
That's it, maybe. But he brought up a good point. In this case, it is a little bit exaggerated because there is no load on this meter. It's spinning a little bit faster. When there is load, it will spin a little slower. So the power factor may appear to be 0.6. Yeah.
Okay, so my life has been in process control as well, so I have a question. What's the maintenance on this and the calibration? How do I know that's well calibrated, and how do I know it's not going to go out of calibration?
Do you have your ammeter or a clamp meter?
So
It is there.
do you see like a life of maintenance on these MPTS?
There is no burden on this. It's a passive electrical network. It's not a generator, it's not a transformer, it's not that. So the only maintenance in this is the filter and the fans per year. Everything else will last you more than 10 to 20 years. So you never have to throw this piece away, because that was the point that I was having a hard time communicating to Johnson Controls, because whether they buy a VFD or a motor control center or a power factor correction device or a power conditioning unit or a voltage stabilizer or a voltage regulator, any of these power solutions that they're buying, they now have to program it. They have to do something with their building management system. They have to do something with their controls. They've got to do something. Here, no. Leave everything alone. This is made for dummies. 4 wires in, 4 wires out. It's self-programming, self-learning. It learns by itself what are the variations, how many spikes it's going to get in a 24-hour period, how high is the spike going. It's self-learning. So, maintenance question, very little maintenance is required per year. Then to ask your question, the smallest unit we make is a 3-phase 100 amp unit to match the 100 amp panel. So we can load it. The next size, which you notice the most popular uses,
So I was just talking about longevity, right?
Oh, okay.
longevity.
The life of that unit.
Okay, okay,
Yeah.
I know. I just found a good place to go in there and tell everybody to go to the website.
Correct.
Yeah.
I will do.
I- I got you. I'm with you.
Okay, one second. So you understand the scalability. You have 100 amp, 225 amp, 450. We made it modular so that you use the same spare part in this unit that you use in this unit, that you use in this unit, that you use in this unit. Okay, that's why it goes 225, 450, then 900. So it'll go a little bit beyond the panel capacity, just so that it is modular, so your maintenance and replacement of spare parts and all that. You can have one set of spares even if you have 20 MPTS units in your facility. If something goes, you can use it, okay? So that's one. The second one which you wanted me to share was, every solution that you know today in energy efficiency is a static solution. It is designed for a very specific application. You know what static means? Like your car is designed to take 5 people, right? Whether you are only one person driving it or 5 people sitting in that car, it is still, the capacity is 5. So your efficiency of that car when you're driving around alone is 20%. So whether it is capacitor banks, whether it is VFD, so you have a fixed design conditions for that specific application in that specific location, and it is static solution, fixed values. MPTS operates from 0 to 100 real time, so it is not worrying whether you had 2 fans on or 2 compressors on or half the panel load is on or off. It works just as effectively at 50 amps or 10 amps all the way from 10% to the full load, it adjusts itself and say, I don't have to deal with 100 amps when there's only 20 amps running through it. So it'll make that 20 amps 20% efficient, so it'll drop the 20 amps to 16 amps. It's a dynamic solution. So when you go to energy consultants, they don't know how to measure and verify this, because when loads are working, it is saving you. When loads are not working, it's not saving. All they know is, if you had 1000 watts of energy in these bulbs in this room, you remove it and you replace it by CFLs, now you're consuming 130. It's a static situation. When MPTS is there, you can have the same MPTS for all the 1000 watts, and you can get your 20% efficiency or 30% efficiency or 40% efficiency, depending upon, it's the same percentage no matter what you're using. But you are going to calculate that you went from 1000 watts to 100 watts, you think you saved 900 watts. Did you save 900 watts, Joe?
I don't think so. I don't know.
Unless all those lights are on for 20 or 8 hours a day, and that was your benchmark. No, but your ROI calculations, solar calculations, they assume that every day, or there are 6.5 hours of sunshine every day for 360 days. And then you get your results at the end of the year, and you say, hey, you promised me $1,600 savings, I got only $1,200. What happened? Oh, this year was the wettest year in the history of California. So what can we do? MPTS doesn't have any excuses for using it, not using it, or whether it's hot weather, cold weather, or whether it is wet weather or whatever. There are no excuses. Now, when they did a benchmark on these lights, maybe 500 watts of this room was never used, but you have 1000 watts. But you figured 900 watt savings, and then you calculated it for next 10 years, and then you got your finance guys to approve it. They signed off. Nobody thought that, hey, if some lights were always off, how are we saving 900 watts on that? That's static versus dynamic situation. You have a question, please.
Yeah, okay, so on this building, existing building,
Yeah.
leave everything the same, hook up your MPTS.
Yeah.
Okay, and there's gonna be a dramatic amount of savings. Let's say we build a brand new building right over there.
Yeah.
Same exact building.
Yes.
High efficient glass.
Yes.
High efficient lighting. High
Yes.
efficient air conditioners.
Yes.
VFCs. High efficient chillers.
Yes.
And hook up your same system.
Yes.
You should see an increase in your savings, correct?
That is correct. That's why now it is getting spec'd into it. So the engineers that are getting it, because they now have incentive from Green Energy Star and LEED certification, which talks about watts per square feet, right? Have you heard of this term? Without MPTS, you have, say, certain watts per square feet. With MPTS, you have lower watts per square feet.
I have a question. Demonstrated on the motor inductive load. What if you looking for, let's say, we plug this up to a bunch of computers. What is our efficiency going to occur when it's a non-inductive load?
Are you from the IT department? He phrased the question very well. What if? That's a big if, because I have not been successful in reaching the IT people, because the IT people have spent $1 million to accomplish the same thing and not get to 95%. They don't want somebody to come and say that we are going to install it. That's why I said it's a big if, because you may not even get that opportunity to do it. But let's say this if, now let's go there. Yes, now I will quote the chief technology officer of a very big, they put marks on the equipment. Every electrical piece that you have, there is a seal on it, okay? So I'll try not to take the word because he didn't want me to take the name of his company. He said, Adil, we are in this testing business. We test all the equipment in this world. We spent $6 million to try and get 90% efficiency in that power quality and that power building, 90%. And he said, after I met MPTS technology, now I sat down and I calculated. He's the chief technology officer for worldwide, all 20 labs. He said, I could have done that, or I can still do that for $600,000. If you get the opportunity to do it. That's a big if. I hope I answered your question. Answer is yes. If you put it on computers, now let's say you have this computer room here and you have certain racks and whatever, you're using computers and you don't have an MPTS unit, you used up the power before you use the real estate. We can install MPTS unit on the panel that feeds all these computers, and we can save 20, 30, 40% of the power on the computer usage. And not only that, we actually protect the life of those computers and the data on those computers so that you don't have the variations of voltage and surges, inrush currents, and now the current levels are much lower. Yes?
What about the cooling? The cooling.
Yeah, for data centers, that's a good point, Don. Air conditioners determine whether your servers are on or off.
Yeah, my question was inductive load versus regulated load.
All electronics is inductive load. They're all active components.
Initial started with.
Yeah, so they're all inductive loads and they have fans in them. They may be small, but what happens is little drops of water make the mighty ocean. So every computer is a little drop of water, and when you have 1,000 computers in your building, now you got harmonics to the level of 50 to 80%. 50 to 80% increases the current by 10, 15%. When you have an MPTS unit, you can mitigate the increase in harmonic currents inside your wire while protecting your equipment. Yes, please.
So can you quantify dollars and cents? If I've got $100,000 a year electrical bill, take me into when the threshold makes your product to make sense.
Okay. Thank you for asking. I love that question. If you have $100,000, I like to know what is the kW associated with this on your bill. And then in that kW, let's say that you have 250 kWs associated with that. And then I will ask you, do you want to save 10% or 20%? What makes sense to you and to your organization to get this solution approved? Let's say you say 20%. So we need to reduce 20% of this number on your bill. So that will be 50 kWs. So we will take this 50 kWs and you can reduce 50 kWs with 2 MPTS 225s. 2. That's how simple it is. This can save you 10 kW to 23 kWs. This can save you from 20 to 30 kWs. This can save you from 40 to 80 kWs. So it's already there. There's a cheat sheet. You figure out how many kWs you want to save. I don't guarantee that because I don't issue that bill. Last year, for that same kW, you are probably paying $8,000. This year, you're paying $10,000. Next year, you may pay $12,000. I don't control that. But if I'm your power provider, I am supplying power to you, I will decrease this by 20 to 40% because I can. I know I can because it's based off of energy. So don't talk to me about this, but somebody asked a question. A good feasible location is a minimum bill of $4,000 and up. Anybody that has an electricity bill of $4,000 and more can benefit from an MPTS unit.
Per month, right?
Per month. This is per month. Per month.
Adil, give us an idea of the typical payout or a range of payout. Somebody spends $35,000 for a unit.
Yes. If you spend $35,000 on a MPTS solution, you could have this paid off in anywhere from 2 to 4 years on an average on a regular 8-hour application. So that gives you a payback of 50 to 25% ROI. Finance guys, stop me if I'm going too fast. Now, in factories and 24-hour applications, you will get this back in less than a year. Yes, please.
The payback and the saving are all based on the type of load, isn't it? Like if you have less inductive load in the plant, your payback will be longer and your percentage will be smaller.
Correct, you got it. There are two main factors on how you're going to increase your payback. Two things. One is how many hours in a day are you using? Okay, the number of hours is a critical factor. If you're using it for 10 hours, your payback is less. If you're using for 24 hours, your payback is more. One typical criteria is hours. The second one is your power factor of the inefficient load. Don't get misled by my building is LEED certified Energy Star building, because LEED certified Energy Star buildings is where we are saving the most energy because they are above 90%. Because when you go inside that LEED certified building, Joe, you have air conditioners. Just because your building power factor, which is an average power factor, the meter is an average value. When you take a power factor here, this is the average of all resistive and inductive and capacitive loads. It's an average number. But in that average number of 0.92, you have equipment that is running at 0.60, 0.70, 0.80, 0.85 PFs. So as Kathy said, we'll only target those loads. So second criteria is pick the inefficient load. So how did we gain market share? Because everybody gave us the hardest job. Kaiser Permanente gave me their most efficient building in the whole country. It is an Energy Star LEED certified. It has a steam seal and everything. And they said, because there were some troublemakers in his team that didn't want to do anything different. They were happy with what they were doing. So they said, if he can show me, if MPTS can show savings in that building, then we'll accept it and we'll run with it. That was 2 years ago. Now it is history. They don't even want to know how much money we are saving or what. Right now they're looking at power quality. We are now installing this unit on the panel that is connected to their sensitive medical equipment, MRI equipment. They have 9 months scheduled MRIs, 9 months. This machine is giving errors due to increase in electronics, increase in VFDs, increase in all the other equipment, because you're putting one solution in a building, it's causing some problem. You're trying to solve that problem, now it is giving you a third problem. Now it is a vampire problem. Now it is affecting this PET scanning, SPECT scanning. It's affecting all sensitive equipment. So now the question is not about how much money I'm going to save, how much revenue is going down the drain that can be stopped by using good power quality. So what was this designed for? This was designed to provide good power quality in buildings, factories, and hospitals or sensitive equipment. NORAD, Cheyenne Air Force Base, does not care about energy savings. They use energy savings, okay, to pay for it. But for them it is reliability, dependability, safety, and fail-safe application, where if this fails, will this stop running? That is the reason they are using it inside the cave in NORAD. Yes, please.
Okay, so when you had your example here, you did a consolidation of electronic panels. How many times in your beta sites or
Have you done
have you had to spend the money to do that electrical panel consolidation? Because there's money there too, right?
That is only, yeah, that's only the labor part that you're doing for this consolidation.
Mm.
Because you are not you are going to use one of these panels, and you're going to make this 30 amp panel up to 80 amps.
Mm-hmm.
So you didn't have to buy a panel. You just had to pay the electrician to move some breakers from here into this.
Okay.
So the nominal increase in your investment is very small compared to the benefit you're going to get. These are installing two.
So I guess my brain was like, in some facilities, those panels aren't sitting next to each other, right? They're in different locations.
In factories, we are beginning to do some of this stuff, or the factories are saying, no, install it on this because we may add more motors. But in commercial buildings, more likely we are doing it. And unless your building is sprawling like a supermarket or like a stadium where you have panels scattered, but all those panels do originate from the same place. So you can catch at the origination point rather than catch it at the
Yeah, we're
end
doing an
point.
installation today where we had to go upstream like you suggested. Yeah,
I was just thinking of some of the factories, okay.
Yeah. Flexibility.
And so then you're just buying a bigger unit.
correct.
Not necessarily a bigger unit. We will figure out what the amps are and then we'll figure
But
out.
if need be, Adil, we can manufacture a bigger unit.
We can
Right.
manufacture a bigger unit. That's right. Yes.
We've got lots of companies here in the valley, mostly heavy aerospace. All of them are working 2 shifts minimum. Several of them are literally working 24/7. So how does that affect payback?
I will ask a simple question. How many of you are familiar with solar energy and solar applications? Are you installing it today? Have you installed solar in this state? You don't have solar energy? Okay. You didn't get into that. But California has the highest amount of solar systems in the country. And it is possible only through rebates, grants, and tax credits. Otherwise, it's not a commercially feasible solution. Even with all the grants, rebates, and tax credit, it cannot do this. Solar guys agree? Cannot do this. So,
Bill.
in California, the answer is you can get your money back in 1 to 3 years in California because your rates are higher.
That's for sure.
And 2 shifts, you could get it less than a year. That's the answer. Yes.
Could I say something to kind of second something
Sure.
you said earlier? Tell a
Sure.
little story real quick. So we're in due diligence with a big global manufacturer, and we're talking, 4,000 to 6,000 units, 150 factories around the world. And the reason we're there is that we are close to the retired president of the company, good friend. And what I can tell you is, in the very first in-depth conversation we had with him, his brain went to, the payback in terms of the electrical savings is great, but it is the revenue side that Adil mentioned. It's having all those machines, working closer to 100%, eliminating downtime, eliminating maintenance. It's the top line impact that, just like that, he saw as the real payback. So all of that, and the lower maintenance costs, the lower downtime, all of that is not even factored into what Adil said.
No, yeah, it's not factored into it. There are five paybacks. Thanks, Don, for bringing it up. Okay. First thing is, when you decrease current, you're decreasing electrical problems in the network. Hot shots, risk to life. Like say in casinos today, in grocery stores today, in buildings today. Earlier, you never had any sockets plugged in. You didn't have a lot of electronic equipment. They used to be mechanical. They became electrical. The current consumption has increased. So what happens is the same panel, a 100 amp panel, which was running at 50 or 60, is now running at 90, 85, 90, 95 amps. It's going beyond the code requirements. So what happens is hot shots are increasing, hot spots are increasing. When they open it, there's an arc flash. And these accidents are increasing because people are not realizing when you're adding electronic control systems and security systems and camera systems and computer chargers. All of us have phones now. All of us have iPads. As soon as we come in, what we do, we have a power strip in our socket. We put a power strip and we pull it in. So the current requirement is going up, and then the safety is becoming an issue. In a casino, there's at any time 10,000 people, 20,000 people. If there's a fire, it's a life issue. So you can't put a price on it. So the 5 major things are, we decrease the current and all current associated risks. You decrease the service, repair, and maintenance. you protect the connected equipment from all the variations, voltage variations and inrush currents and harmonics coming from the outside. You're protecting this equipment, number 3. Number 4, you are increasing the life of this equipment because it is getting clean power. So when we put all these benefits in front of a CEO or a chief of operations or a chief engineer and ask them, pick top 3. The last one, the 5th one is utility savings. When you put all these 5 points to a decision maker, I don't see them picking utility savings at all in those top 3. Thank you for bringing it down, because that revenue and downtime and that service, repair, maintenance, capital expenses to replace the equipment is a lot more damaging than electrical bill savings. Like UNO Pizza went on a binge to install VFDs. They were so happy. They were getting $250,000 checks in rebates from the utility company, electrical utility company. They were super thrilled. They said, oh, $250,000. My salary is only $80,000, so the company is not paying me. I brought $250,000. So, boss, you're not paying me. Company is not paying me. Guess what happened? They had vampire problems. Computers started going down. The compressors started failing. Motors were failing. Kraft cheese factory in Chicago, serviced by Schneider Electric. They installed 7 capacitor banks. They installed I don't know how many VFDs, motor control centers, and then after they commissioned it in December, January and February, they lost $40,000 worth of equipment and the factory was not running. It was down. Who do they call? They called MPTS and they said, Adil, what do we do? What do we? I said, first tell me what you did to cause this. That's when I found out what they did. I said, start turning some of the things that you have installed, disconnect it or turn it off immediately. First step. They wanted to simply go install an MPTS unit to offset the damage it was doing. You could do that. UNO Pizza is now installing MPTS units along with their VFDs to just compensate for the balance. Right? Because it's a power quality improvement device. So any power quality degradation or power quality goes down by adding some of the other power solutions. You can compensate or mitigate it with using an MPTS unit to keep it within working limits. IEEE or National Electric Code, you can bring it within the requirements.
So Adil, so if we're hearing, wow, this is so good to be true, Adil just invented perpetual motion machine, which we know doesn't exist, right? So without giving away your IP, you tell us what it does. Can you tell us about how it does it?
Yes, maximum power transfer theorem was written by John Moritz Jacobi in 1840. You can Google him, he's there. Maximum power transfer theorem. Maximum power transfer theorem says whenever you turn any of the loads on, resistive, inductive or capacitive loads, when you turn it on, it creates headwinds. Headwinds are referred to as electrical power losses in the system. So when you have headwinds in an electrical network, it makes everything harder to function effectively and efficiently. So the maximum power transfer theorem says that if you can, it was a hypothetical statement made in 1840 and he wrote a physics equation that you can make kW equal to kVA. kW equals kVA. So when you do that, what happens? Power factor is equal to 1. That means to say your losses are minimum. That is the theorem. It's popularly known as Jacobi's law today. Okay, Jacobi's law. So what MPTS unit is doing is, it is sensing the waveforms both on the source and the load. It's a passive piece of electronics that is sitting in between. It's passive piece of electronics and it has an RLC network attached to the motherboard. What it is doing is, it's watching for all these variations that are coming and then it is minimizing those variations. Therefore, the headwinds from both sides are reduced. So maximum power is transferred from point A to point B. Maximum power transfer theorem states that maximum power can be transferred from point A to point B if you decrease the electrical losses in the system. So this electronic network, this technology decreases the losses in the network, thereby increasing the efficiency. It's not the other way around. You're not increasing the efficiency using something to increase the power factor. The power factor goes up because the efficiency increased. So that is one answer. Another simple answer is, picture is worth 1,000 words. If you,
The first person needed 2 grease boards in this room, you know that.
And it's funny, he asked me, would it be all around the room? I said, yeah, like you're going to use it.
if you can make this whole thing a wall, it'll be good. So now think of this as a balance. If you go to any courthouse or a federal courthouse, there's a balance and it says sign of justice, right? Balance. Think of this as a source side of power in a building, and this is the load side of power in a building. And then you have voltage and current in this, and you have voltage and current in this. What's happening is voltage and current is constantly bubbling on both sides. So what's happened to the scales? Sometimes this weight is more, sometimes this weight is more, sometimes this weight is more, sometimes this weight is more. So they are doing this. So what does MPTS do to make all this thing happen? It absorbs all these shocks from both sides and doesn't allow the variations here seen by this side and the variations from the load seen on the other side. So it maintains this constant balance at a very high speed. 20,000 transactions per second it is capable of handling. But our system is only 60 hertz, 60 cycles per second. So this is more than its old design. It's like using a bazooka to kill a sparrow. So, right, I mean, you just needed maybe a .22 pellet gun to kill it. But this is like using a bazooka, but it is sitting there waiting and say, give it to me, give it to me. So all the variations that are coming, it's taking it out and removing it to the ground through the neutral. So that is exactly what MPTS is. It's a passive piece of network which, when something shows up that needs to come, the motherboard says, okay, I want that. I want this. And then it takes it out and puts it out. It removes it from the system. What do other solutions do? They add something to the network. So MPTS itself is not using any power. It's using 1 amp for every 100 amps. So the burden of the MPTS itself is nothing.
Capacitors could run 5 or 10 amps.
Yeah, say 10 amps. Yeah, as you go. Yeah. 5 or 10 amps is nothing. Your iPad is 1.8 amps. So 5 of you are using iPads. It is more than what the biggest unit is using. You like that relationships?
You know me, I'm very elementary. I like that.
So if somebody says, hey, what's the burden rate and you're using power, it's becoming a load on the network? No, not any more than the 5 guys that came and plugged in their iPad chargers. So, yes, please, Kat.
So, it sounds like you're getting written into government opportunities.
Yes,
right?
yes.
And some other larger opportunities. With that factor in there, have you worked with states or governments or countries to get rebates the way the solar industry has?
It's a catch-22. In Colorado, we tried very hard because the world headquarters for Transpower is in Colorado. We tried very hard to work with the utility. The utility demand side management, as much as they want to decrease the demand and the thing, 60 to 70% of the electricity bill is in demand. They are happy to reduce your kilowatt hours all day long because you're dealing with less than 30% of your total load. When you get into MPTS unit, we are getting into that other 70% of the load. In that other 70%, if you're going to save 30% of that load, it's a significant decrease in that billing that you talked about. So that's one reason why we were having a little bit of difficulty in working with them. The second reason is they now tell the customer, this is not in your best interest.
But we are
now working
with the
with
National Energy Market Association out of Washington, trying to build in a platform for that.
We have 3 utilities right now that are very much in favor of this. So even with Excel Energy in Colorado, it's a love-hate relationship because there are substations and neighborhoods that are overloaded. There are new there are new substations which are not yet utilized. So they are happy to deploy these solutions in those areas which are congested. So Los Angeles Water and Electricity Department was very open to it. United Power in Denver is very open to it. IREA is very open to it. Niagara Power Utility came in and did a whole 12-month study and gave us a report of what they saw. It's running at 1.00 power factor on their bill. It's probably 0.995. So it is. So now the utilities are coming around. We are now working with the United States government that took me to PowerGen conference in Florida last year, and from there I got invited by the State Department to go make presentations in the countries where United States government has signed a carbon dioxide reduction treaty to decrease the burning of this coal. Because when you reduce this from 1,000 to 10, say 1,000, let's say you reduce this from 1,300 to 1,000, you're burning less coal here. If you're burning less coal here, you're putting out less carbon dioxide here. So United States has a treaty now with China, has a treaty with India, with Middle East. So Middle East is putting up 1,500 megawatt coal plants in a hurry because their growth has been sporadic. They have built 3 New Yorks in the last 10 years in Dubai alone. There are 3 New Yorks, high-rise buildings. So I went there to make a presentation to the utility company. So Saudi Electricity Company, they're friends of United States, Dubai Electricity Board. So all those. So now we have units in Middle East. We have units in Canada. So we are now getting interest from worldwide participation in this technology. So it is happening at a lower level. What's happening, like you asked me, people are saying, okay, this is the job for decision makers. This is the job for CFOs or CEOs or board of directors.
But we're starting to get the power companies. Garden City Power in Long Island just became a customer. So we're happy that they're starting to come on board. LADWP was very open. Terry over there runs it. We had a great meeting, and he was very receptive to this.
So is this all US made right now?
Yes. No, it's made here.
Everything in this product is UL approved.
No,
the
US
wires,
made. US made.
And then, I mean, anything that UL made is for United States of America. And the whole product is done, and it's made in Atlanta, Georgia. Actually, we have contracted with the Sienna Group. You can go on website and check the factories out. They have factories in Chicago, they have it in California, San Francisco, Atlanta, Georgia, and India. So they will make it in any of their 4 locations. The reason we picked them was because they're also a defense manufacturer. They manufacture product for defense. So because we are gaining a lot of ground in the Department of Defense, that's the reason why we wanted to have a manufacturer that can cater to their requirements. Yes, please.
Your experience in Mexico?
Lot of interest. Lot of interest. But I haven't seen action yet, because they're using diesel generators as prime source of energy, especially for all their resorts and islands, and in Mexico itself, they don't have enough power. So what they're doing is they have diesel generators. Diesel generators efficiency is 60%. So they're very interested, because the cost is not the cost of just the power. It's the cost of the diesel and transportation and storage. It's just like the mining and the remote operations locations in the United States. We do have some units in Mexico they're evaluating, because if you have to use that in Mexico, it's a question of 2 or 3 families, I believe, making a decision. So the people in control, and then there are some industrialists that control the economy. So it's going on, but I am not directly involved. So so
I'll take all questions for Mexico.
Just a little bit about the green savings, the carbon footprint.
Yes,
We did, Bob.
we just shared about it. He's asking a question about going green, because right now, if you want to go to the board of directors or the leadership, their corporate social responsibility is increasing. Corporate social responsibility means, if you go to the website of Kaiser Permanente, Walgreens, and all these companies, you will see one of their objectives is reduce the carbon footprint. and also reduce the watts of power that they're generating and the coal that they're burning. So instead of talking about energy savings and payback, if you want money to be approved, they're doing it in the name of corporate social responsibility because it is good for the people. Because I got into energy conservation 30 years ago so that we don't have to wake up in the morning and wear masks to go to work. That's why I got into energy conservation
Like China.
and energy efficiency. India, China, all these people, you see, they're riding motorcycles or going in trains, they're wearing this masks. But if I came and told you that I am selling clean air, you put this in, please spend $100,000 so we can all breathe clean air, you'd just throw me out. You wouldn't be sitting here for 2 hours. So we have to tie it up to finance. But the corporate social responsibility today all over the world is we need to do good to humanity. The population of the world is 8 billion people. And Kaiser Permanente is in healthcare. So healthcare means going green.
Explain that every ungenerated.
Yeah. It's a negative watt. Let's say that if you reduce 1 kilowatt here, you don't have to produce that 1 kilowatt. The effect is actually double. And the new coined phrase is negawatts, N-E-G-A watt. So what happens is, for every watt that is saved here, it is almost like you are reducing the watt that is generated from this.
Well, the carbon footprint and the mathematical equation would be, if you were saving 1 watt here, would be 9 at the beginning.
9 pounds of coal.
Yeah. So
It's multiple.
Saving versus the solar is a different way to look at it because it's generating power. But if you're saving power, you not only have the loss through your lines, you have the loss through the manufacturing process of the electricity, and you have the loss that comes from mining the coal.
That's right.
So it's a 9 to 1.
9 to 1 ratio. That's the contribution. So that is the social responsibility part. Like right now, this also came from the UL themselves told me, Adil, focus on corporate social responsibility, negawatts, and going green, and decreasing the carbon dioxide that we are putting into the atmosphere. Then you're getting budgets. Because operations, people in operations thinks that I don't have money to run my operations. How am I going to get money to do a new technology? That is, at that level, they're 100% right. But if this information goes up from their desk, if they're bold enough to take it up the ladder to their management and to their board, the board will recognize the benefits of this and they'll make money available to do it. Right? Have you seen a management wanting to do a party in Las Vegas or in Bahamas and then they say that, hey, we are under a price cut? We are on a capital freeze? Has that happened?
Not first class travel, but.
First class travel.
I have a corporate jet, so you have to
Yeah, corporate.
CapEx freeze.
Yeah.
So do you have leasing opportunities as well? So if somebody has a CapEx freeze, you can take care of that CapEx issue.
Yep.
Just with
Yes.
utility savings, you'll be able to fund your lease.
Yes.
So then they get to enhance the,
Network.
minimize the downtime,
Yes.
heat signature of their equipment, maximize their uptime, and also their revenues at the same
He
time.
brings up a beautiful point.
So
There are
all
many
this-
ways. Yeah.
Your return is far more than a 1 to 2 year, it's far less than a 1 to 2 year payback.
Yeah. That is
It's-
true.
Exactly.
In the right industrial setting, it could be months.
That's right.
Exactly.
That's right. Yes.
What is the name?
MPTS.
MPTS. What is the recommended threshold to advise the installation for power factor correction or efficiency? Is it something anything lower than 80% or something lower than? What is the anticipated threshold that you recommend on an upstream or a downstream? Both might have different efficiency, but what is your recommendation?
Anything less than 0.85, if you have any equipment less than 0.85 or 85% power factor,
On the
you
upstream
can.
or on the downstream?
Doesn't matter. Doesn't matter. Because if you have 0.85 upstream at the meter, that means you have 0.4 and 0.2 and 0.1 power factor at the downstream. So you ask me what is a quick thumb rule. where do we go put this MPTS unit? If you see one panel, which is 0.85, or if you see a main distribution panel, actually on the main panel, if you're 0.95, it is actually better. Because every amp you save, you're saving 0.83 kilowatts of power. So people can get the arms around this. The higher the efficiency at your upstream main meter, the more payback you're getting with the MPTS in that network.
Can you explain that again?
Hold that thought, yes.
I have customers who, the new technology is battery storage.
Yeah.
And so they're looking into and asking me to evaluate that for them. How does this compare with battery storage, or is it a alternative to battery storage?
The first question is, why do they have battery storage?
To eliminate the peaks in the demand during the periods of day where it's expensive.
Yeah, you can eliminate those batteries if that is the reason they're using the batteries.
Why would you say that?
Because they're not using it for uninterrupted power supply. They're using it for variations in the current.
No,
And
if you have the power stored,
yeah,
you have that 6 months a year where you have your peak periods.
yeah,
And you have different rates. And when you get past 12 o'clock to 6 p.m.,
yeah.
you're paying like 35 cents a kilowatt hour. And you're using like 11 cents in your mathematical formula over here, a little bit over.
Mm-hmm.
So if you take 35 cents and you're able to use your battery power that you restore the batteries to full capacity so they're ready for when your demand comes from the peak. You do that at night when it's much cheaper. And now, so you pay much less, say, 4 to 8 cents a kilowatt hour. And now you're tapping into it when it's costing you 35 cents. Your efficiency helps greatly. But when you have that much demand, that battery power brings you down. So you don't go up to that higher level where you hit 35.
Perfect.
You're staying down there around 15.
Yeah.
So that's a huge savings. Operation.
As an engineer, I'm very black and white, so I was very literal in answering his question. But he added a little bit more to that. If you have batteries, keep those batteries. Like Coors Brewery and this thing, they operate 24 hours a day. All these breweries, Molson, Miller, Coors Brewery.
They're just considering them right now, so that's the next.
So what they're trying to do is yes, question?
I was gonna say, with the batteries, it would seem like with the MPTS, you're gonna get more efficiency out of the batteries are providing the power. So you don't have to have as much battery, or the batteries will last longer.
Batteries will last longer. That is the key. You can use, that is what William here said. Yeah, if you have an MPTS in an environment that has batteries or VFDs or whatever, you just increase the life of those batteries. You made those batteries work less harder. So you actually have less stress on those batteries because of the variations. Because your rectifier is the main part in your battery backup system. Because you're taking AC, converting it into DC, then you're taking DC, putting an inverter and converting it back to AC. So you yourself created a loss there, and you yourself created harmonics there, because the highest amount of harmonics are coming from rectification from AC to DC and then from DC to AC. Very good point, David. Very good point. So you use this in conjunction. Don't change anything like you said. You already have a battery backup system. Go put an MPTS. Always put MPTS upstream of the solutions that you have. Don't let a battery feed an MPTS unit. So basic thumb rule. Always make MPTS feed power downstream to batteries, to VFDs, to compressors, to all these loads. Because rectifiers send out harmonics upstream or downstream or whatever. So when those harmonics are actually being fed into the unit, the electronic network here can get into resonance. I'm getting into technical area. Forget about it. We don't want to. But install it upstream.
You want to be careful with that recommendation, I would think.
Yeah.
I think you'd also have some kind of a limitation on how far you're distributing from that main panel. I mean, depending on the length of your building, how far you're distributing it out to sub-panels. Or is there no limitation in terms of its added efficiency it's introducing?
Closer to the load provides you bigger benefits and better savings. Closer to the loads. So go downstream, because the solution was designed to protect equipment and reduce the current in the entire network. If you go upstream, you are not getting the benefit of lower currents being drawn from the meter all the way to the rest of the building. You see, if it is farther away downstream, if the unit is farther away from the meter, you have line losses, I squared R, for the entire distance and all the panels and everything. So closer, yes please.
From 50,000 feet, take me through a client story, would you, about how they figured out whether this is going to work for them or not?
Yeah, very, very good. We go to a client, or we did 4 years or 5 years ago, when we went, even before we had our UL listing and before we had our patent, we produced the commercial units and prototypes and commercial units, and we approached a customer and we said, Mr. Customer, it was relationship based. I said, Bob, you're my friend. I have this product. Can you please allow me to put it into your business or your factory or whatever? Liquor store was the first installation in America. Largest liquor store in the country with a lot of freezers, compressors, lot of variations. Compressors are coming on and off. So we went and took permission to put it in that. He said, you're wasting your time. I have done everything. He had spent $220,000 on a power conditioner to take it to 0.90 on the main panel because the utility had told him, you have to get to 0.90. You are a demand on my substation. He discouraged me from coming and putting it, but because he was my friend, he said, okay, bring it in and put it in. The moment I put it in, his power conditioner had taken the efficiency to 0.86 at the meter. We went to 0.98 as soon as we turned it on. And the current went down by about 16 or 18%. That was my first experience where the electrician doesn't want to believe me, the customer doesn't want to believe me, my friend says you're wasting your time, I have done everything. So that's how we started.
So you got all your liquor free after that.
We have about 7
Let's have a party.
we have about 7 minutes.
Yeah.
Did you want to go back to his question about how, when you have a higher efficiency factor, just to make sure you understood that?
Yes, yes, yeah. A green building is usually 0.93. We have an equation somewhere here where I said KVA. KW is equal to KVA times power factor. Right? In this equation, we are going to reduce amps. Right? If this is 1, the kilowatt savings is greater. If this is 0.85, the kilowatt savings is a little bit less. Mathematically, that's the easiest way for me to share that with you, because if you multiply KVA times 1, that is more kilowatts. If you take KVA times 0.85, then it is less. So what we do is, that's why we are focusing downstream and making sure that this power factor is getting closer to 1. The whole building power factor is going to 1. Then what happens, every amp you save has a 0.83 kilowatt decrease on your, realistically, on your bill it may be more because the utility bill is not billing you for actual consumption. They are billing you for the peak, so that if you are consuming 1 kVA in our calculations, we are talking about real power, your bill could be 2 kilowatts or even 3 kilowatts, because that was the spiked up value, the highest value in a 15-minute period. So if you save 1 kVA, what is the decrease on the bill? Not 1 kVA, it is 2 or 3. So whatever we save is actual values you are going to save. What's happening on the bill, I have no idea. Last 5 years I have tried to figure it out. The more I think I learned something, the more I know that there's more to learn. But I learned all this. Yes, David?
A question was asked earlier about, without giving away all the technical side, what does it do? And one of the things you've been focused totally on the reduction of the watts and so on. You haven't really talked about the matching of impedance and the reduction of total harmonic distortion, which is the heat which saves the equipment and things like that. Is that?
That's why I asked who's in this room when I came in. And if I use the word impedance and harmonics, then I have to go into the definition of what harmonics is and what impedance is and how that affects the electrical networks. And so then I'm going to make everybody yawn and go to bed here. So didn't want to do that. But that's a very good point,
So
though.
I'm sorry, what is the price for every kilowatt that the equipment, for every kilowatt that the equipment is rated, what's the price for every kilowatt capacity?
You can, Amici, all technical questions to me, commercial questions go to,
Yeah, we would have to.
They have the
assess
whole team.
facility, see
Yeah.
what kind of power is going into that, and then we'd come and give you an assessment on that facility of what the cost would be.
but it is very easy. It is based off of KVA. For every KVA you save, there is a price. So you can figure out how many KVAs you're planning to save, or how many KVAs are you planning to run through the unit, or basically voltage is constant. How many amps do you want to run? So based on that, if you have 100 amps, they'll give you a rate for per amp. Yeah. Very easy to price it. You don't need to go on a computer and all that. You can just do it on the field. Yes, please.
You say all the components are UL approved.
Yes.
So that unit itself is
Also UL approved.
Okay. So two-part question. Do you have it gone through any other testing labs in California, such as ETL? And also, are there any test data that's available?
Of course, yeah.
There's too much data available from testing in the last
Yeah.
so many years. We have a lot of testing.
Yes.
Answer
It's
is
not
yes.
only UL approved, UL's a customer too, by the way.
Pardon?
UL's a customer also, by the way.
I think in here you've got a UL.
Test certificate.
I'm
Or
more
test it.
interested in the testing data of the unit itself as sort of,
Sure.
I was going to go to, a client and suggest it, they might say, well, show me the testing.
Yeah, on our website, we actually have a flip book that has power bills and testimony.